Welcome back to a new machine learning tutorial. In this video we are going to talk about logistic regression. We are going to talk about the logic behind the algorithm and we are going to code it using Python scikit-learn. Let's start coding. I'm in VS Code. You can use any code editor that you want. I prefer this. I will be closing the welcome page and I'm going to creating a Jupyter notebook named Logistic Regression for this tutorial. I'm going to go with Jupyter notebooks. I'm going to select the kernel, quickly in here. Next up, I will say logistic regression, and let's talk about it. So this is a supervised learning algorithm used for binary classification tasks like 1 or 0 or dog or cat, two classes. Unlike linear regression, which predicts a continuous outcome, logistic regression predicts the probability that a given input belongs to a certain class, typically between 0 and 1, as we talked. The model uses the logistic function, also called as a sigmoid function, to map the predicted values to probabilities. So let's talk about its mathematics. In here, we can write its formula, like we can say this is going to be the probability of the positive class. I'm going to say y equals to 1 on x, and then I'm going to say sigmoid function. We are going to be talking about this sigmoid function, and we are going to have weight 0, then weight 1, x1 multiplied by x1. We can write it like this. Also, we need to use plus in here, and if we add space, it's going to be much clearer, and we can add multiplication in here too. So I'm going to say weight 2 multiplied by x2, and it goes to the weight n xn, like this. So we have this formula in here, and we are going to talk about the sigmoids formula in here too. And let's go over this formula. So this is the probability of the positive class, and here we have our sigmoid. Then the w's in here are the weights, which we can also refer as model coefficients, and x's are the input features we have. Like we are going to give the x's into the model, and we are going to take the probability prediction for the y in this model. So this is our formula, and at the sigmoid side we have this, and we can say like z in here, and the formula of the sigmoid function is, we can say 1 divided by 1 plus e power minus z. We can write like this. So this is going to be our sigmoid formula, and this function squashes any real valued number into a range between 0 and 1, making it suitable for probability estimation. For example, let's say like it returns 0.6, so then it's going to be around 1, and our predicted class is going to be 1. Okay, so let's create our data set, and we can start coding. I'm going to say import numpy as np. I'm going to say import matplotlib.pyplot as plt, and I'm going to import make classification from scikit-learn.datasets. So after importing it, I'm going to create my data like x, y, make classification, number of samples 1000. Let's work with a 1000 point dataset. Number of features is going to be 2. Number of informative is going to be 2, and so number of redundant is going to be 0. Then I will say like number of clusters per class is going to be 1, and let's set the flip y as 0. So this is how we are going to create our data for this tutorial, and let me show you the x matrix we have with the y vector. So it's a binary classification problem, since we have zeros and ones in the target, and then I'm going to be closing them. Now let's create a simple visualization for checking how our data looks. I will say plt scatter, and I'm going to say x, y equals to 0. I'm going to filter it in this way. Then I will say 0 like this, and I will say x, y equals to 0, and I'm going to take them like this again. Instead, I'm going to be using 1 in here, and let's color it as blue and give it a label like class 0, and then I'm going to be copying this for creating the class 1, and I don't want to type them all again, so I just want to change them by copy and paste one. And now let's change the cover as red, and it's going to be class 1. So we can give it the X label like feature 1 and Y label like feature 2, and we can say plt.legend. So if we use plt.show, our code is ready for the visualization. So here is our dataset. We have the class 0 in here, class 1 in here, and we are going to do classify this dataset. So when we see a new data point and don't know its class, we can predict like this class is going to be 1 and this data's class is going to be 0, and we can make predictions like this. Okay, let's create our base model. Firstly, we are going to train a base model, then we are going to do parameter tuning, where we are going to optimize the model's parameters. And for a quick overview, most of the machine learning models have parameters that we can optimize for getting better performance from them. So I will say from scikit-learn model selection, import train test split. I will say from scikit-learn.linear model, import logistic regression. And I will say from scikit-learn.metrics, import accuracy score. Then, by the way, train test split for the splitting our data into training and testing sets, and accuracy score for evaluating the models we create. I will say xtrain, we are going to start with train test split, xtest, ytrain, ytest, and I will use train test split, x, y, and test size of 0.2. By the way, I have a tutorial on this topic, so if you don't know this topic, train test split, you can check that video, or I'm going to summarize it real quickly. But I have a machine learning tutorials playlist where I have 40 videos just like this one. You can check for learning the machine learning concepts. So our test size is 0.2, which means that we have the 20% of the data in the testing set, and 80% in the training set. So let me quickly write it down. Training set and testing set. We have 800 in here and 200 in here. So we have this, and let's write it like this, and I can show you by length of the y-test in here and length of the y-train. We can write this. So xtrain and ytrain are our training set, and xtest and ytest are our testing set. So we are going to be training the model with the xtrain and ytrain. Then with the trained model, we are going to make predictions using xtest, and we are going to compare the predicted values on the true y values, which are ytest. So let's do that. We are going to initialize the base model, like I will say model is going to be logistic regression, and I'm going to train my model using fit method on xtrain and ytrain. Again, these are our training set, and now I will do model.predict. I will do the prediction on the xtest, and we are going to get a vector like this, like zeros and ones, and I will say y prediction and save it like this. Now if we call the accuracy score on this, we can say y true, which are our y-test, and we can say y prediction. So actually, let me fix the typo. We are going to have 0.995. So this is quite high. Accuracy can take values between 0 and 1. So let's change our data a little bit. I don't want it to be this high for this tutorial. So let's do the number of informative and redundant like this. So I'm going to be saying 1 for all of them. Then I'm going to make this rerun, and we are going to, I don't want this data set 2. I will do this. Actually, let me quickly say 0 in here and see what we are going to get quickly. Okay, now it looks better. We can also try another one, maybe. Completely up to you, by the way. Like, we can work with this too. Okay, so I'm going to make them run again. Train test split, model initialization, model training, predictions, and accuracy score is going to be 0.93 this time. And when we say run all again, we are going to have different accuracy values each time. But in real life datasets, it's not possible. So what we need to do is we need to improve our models. since we can change our data like this one. So how we are going to do that is, we are not going to touch anything in this side, and we are going to be only focusing on improving the model's performance. And this is the place that we are going to be talking about the hyperparameter tuning for getting better performance. And for the quick recap, most of the machine learning models have parameters that we can optimize, and when we optimize them, which is a process that we call hyperparameter tuning, we can get better performances from models. So for the logistic regression, we are going to have C, which is the inverse of regularization strength. Smaller values specify stronger regularization. It controls overfitting. And the other parameter we are going to be tuning is going to be the penalty. And this is the norm used in the penalization. Options include like L1, which we can also use as lasso, L2, which we can also refer as ridge, and elastic net, which is for both. And we are going to use solver. And this is the algorithm to use the optimization problem. So let's tune. I will say from scikit-learn.model selection import grid search cross-validation. Then I'm going to define something like parameter grid, and it's going to be the possible parameters that our model take. And I will say for the C, I'm going to give values like 0.1, 0. Actually, let's add 0.012. You can extend this list in the way that you want, but I'm not going to do a lot in this video. I want it to return quick. Then I'm going to say penalty is going to be L1, L2, bridge, and elastic net. Next up, I will say solver, and for that I will say liblinear and Sega, like this. Now I'm going to set the grid search like this, logistic regression. I'm going to give parameter grid on parameter grid. Then I'm going to set cross validation in 5 folds. I have tutorial on that too. You can check that playlist I have in the channel, which I'm going to be adding in the cards. But this means splitting data into 5 parts and training the model with 4 parts we have, and it's going to test the models with the 1 part we have left. So I'm going to save this to something like grid search, and it's going to be equal to this. Next up, I'm going to say grid search dot fit, and I'm going to give my training set in here, x train with y train, and it's trained. Now we can get best parameters using grid search dot best parameters like this one, and it's picked 0.01 for the C, penalty is L1, and solver is Sega. So let's see if we improve the performance. So I'm going to make predictions with it using grid search dot best model, best estimator, dot predict, and we are going to make the predictions using x test, and actually it's grid search like this without underscore, and we return an array like this, and we are going to compare them with actual values we have on here, accuracy score y test with y predictions tuned like this. So let's see our accuracy score, and it is 0.95. so let's see the base model performance. It was 0.88, so we improved the model's estimation performance using grid search like this. And let's summarize what we do in this video. So we start by talking about the logistic regression and its prediction logic. Then we talked about the mathematical formula it had, like the sigmoid, weights and inputs, and predicted class 1 probability. Then we talked about the sigmoid math. Then we create the data set, and then we import train test split, accuracy score, and logistic regression. We also make a visualization on the data set. I remember it like this, but I don't know where it is. Maybe I deleted it by mistake, but we also did that. And we imported accuracy score for model evaluation, train test split for the setting our training and testing sets, and we make train test split. We talked about its logic quickly. We initialized the base model and we fitted our base model, which means model training. We make predictions with it, and we compared the predicted values with the actual one, and we found the accuracy score as 0.88. Next up, we talked about the parameters we have, and we set a grid for them, And in grid search, what we are doing is we are trying every parameter combination and returning the best one. So we set it and we make predictions with it after training the grid search in here, and we get our accuracy score as 0.9, which means that we improve the model's performance on predicting using grid search. And here are our best parameters we have on the logistic regression. Thanks for watching this tutorial on logistic regression. I have a machine learning tutorials playlist where I have more than 40 videos just like this one. You can reach that playlist from the cards of this video or from the description. I'm sharing new data science videos every week on my channel. You can subscribe for more videos like this. Have a great day.